Back. I hope you're enjoying the lesson so far and you're working hard during class, and I look forward to seeing you in a few days. So let's get started on pre-class and select your answers on Edpuzzle. So for today's lesson, we're going to move into section 3.3 and we're going to graph systems of linear inequalities. So we've kind of done this before. Now we're just going to tie several things together. So first, let's define key concept. The following is an example of a system of linear inequalities. So system means one or more, it means more than one really, okay? And we're talking about linear, so we're going to have lines. And now we're going to do inequalities, okay? So if you remember when we were graphing inequalities at the end of chapter 2, we were shading regions, okay? So and also a solution was a single point before in the previous sections. Okay? The problem with inequalities are that there's many possible solutions. So what we need to get is all possible solutions of that system. So what we're going to be graphing is what's going to be called, or I call it, a solution region, because there's going to be many that are going to overlap. So how do we do this? Well, we're first going to graph each inequality in the system. I recommend using colored pencils to distinguish between the different shadings. What you're going to be looking for is the overlap of the two different colorings. If you don't use colored pencils, you just have to be very careful. Shade one direction and use another direction for another graph. And then just identify the region that is common to all graphs. That region is the solution to the system. Okay, and remember, I call this the solution region. Okay, and in real world, it's also referred to as the feasibility region. So in the business world, you call that the feasibility region. All right, example 1. So graph the system of inequalities. So we have two inequalities, and we're going to graph it. All right, so y is less than or equal to 3x plus 2. So if you recall, what we're first going to do is graph the y-intercept. Let me use blue for that. So we go up to plus 2. We graph the y-intercept. The slope is 3, so we go 1, 2, 3 up over 1. 1, 2, 3 up over 1. Remember, we stop and think. It's less than or equal to, so that means we're going to draw a solid line. All right, we can test a point to figure out if we're going to shade below or above, but the shortcut is less than, so I know I'm going to shade below. So it's going to be all areas over here. All right, now moving on to the red. Plus 4, so we're going to graph plus 4, which is right here. Slope is down 1 over 1, down 1 over 1, down 1 over 1. And this is a dashed inequality. There we go. Again, we can test points, or we can figure out that we're going to shade this way. Okay, so if you notice, the region that has both shadings, okay, so this region here is my solution, and I call that the solution region. Okay. Any questions? Good. Moving on to example 2. Let's try it again. All right, so let's graph the first equation. Now, for this one, before we go ahead and graph it, you could, I think, use the intercept method, but for some of you like to solve for y, so let's go ahead and do that. So we subtract 4x from both sides. So we have 2y is greater than or equal to negative 4x plus 8. And divide everything by 2. So we have y is greater than or equal to negative 2x plus 4. So let's graph that. We go to plus 4. We graph the y-intercept. Go down 2 units over 1. Down 2 units over 1. Down 2 units over 1. It is a solid line that goes through those points. And we're going to shade above. So here's my region for that. Now for the next equation, we go down to minus 3. My slope is negative 2, so we go down 2 over 1, down 2 over 1, down 2 over 1, and we have a dashed line. It looks something like this. And we're going to shade below, so it looks something like this. All right. No overlap. What do you think that means? I know. No solution. There you go. Okay, example 3. Let's graph these two systems. All right, again, so let's do blue for y is less than 2. All right, y is less than 2, so we're going to go ahead and do this. You know what? I don't like that. Let's delete that. I meant to do something else, so I'm just going to get rid of that. All right. So what we're going to do again, try it again. We want dash line anyways. So I completely messed that up. Dash line, y is 2. And we want less than, so we're going to shade anything below that line. Looks beautiful. All right, next. Absolute value. Okay, so again, for those of us still having trouble with this, we can always do an XY chart. All right, in our XY chart, the value of my vertex is going to happen when the absolute value is 0. That happens when x is positive 1. And we're going to pick 2 points below, and we're going to pick 2 points above. So we have the absolute value of -1 minus 1, and I think we get 2. We have the absolute value of 0 minus 1, and I think we get 1. We have the absolute value of 1 minus 1, and we get 0. We have the absolute value of 2 minus 1, and we get 1. And we have the absolute value of 3 minus 1, and we get 2. Plot those points. We have -1, 2. All right, we have 1. I graphed that wrong. All right, fix it real quick. All right. All right, so let's go back to my red. We want -1, 2. -1, 2. Oh, maybe I did that right. Okay. 0, 1. 1, 0. 2, 1. And 3, 2. Greater than or equal to. We want a solid line. And we want solid line. Test a point or shade above. Oh, look at that. This little area right there, both shadings, that is my solution region. Okay, I think we're getting the hang of this. Okay, so let's try guided practice 1, 2, and 3. All right, let's try guided practice 4, 5, and 6. And let's summarize the lessons. So how do you find the solution to a system of linear inequalities?